.5 seconds after it was dropped from the bomb bay of the B-52, a thermonuclear device detonated on target off the coast of Christmas Island. This event started the shooting phase of the longest, the most complex, and quite possibly the most successful series in the history of United States nuclear testing. This particular story is told from one point of view, that of the United States Air Force, and the part Air Force men, missiles, and aircraft played throughout the 1962 test series known as Operation Dominic.
For the Air Force, the operation started in September 1961 with the Soviet resumption of nuclear testing. A directive was received from the Joint Chiefs of Staff to develop a capability to conduct on extremely short notice a limited number of atmospheric nuclear tests over the open ocean south of Hawaii. Air Force response was in the form of an operation plan, codename Ever Ready, providing for an all-airborne drop and diagnostic array. The array would consist of an RC-121, functioning as an airborne operations control center, a B-52 for the aerial delivery of the test devices, 2 heavily instrumented C-130s to record diagnostic data on device behavior, and several B-57s to provide a limited cloud sampling capability. That operation plan was shelved in mid-November of 1961 when the newly formed Joint Task Force 8 began planning for a full-scale test series. The new approach called for some 20 airdrops into an extensive, highly instrumented shipborne array on the open ocean south of Hawaii, plus a few missile-launched high-altitude events from Johnston Island. The first airdrop was scheduled for 1 April, a short 4 months away. The first Johnston Island event, a full-scale dress rehearsal including a missile launch with an inert warhead, was due just 1 month later. Another change took place when the airdrop phase was shifted to Christmas Island on the 17th of February. This was not an unexpected move, however, since such a contingency had been written into the plan. This moved the airdrop operations 2 degrees above the equator, or some 1,200 miles to the south. The Johnston Island operations remained as planned. Here, for the first time, it was possible to say, Operation Dominic has firmed up. On the morning of 25 April 1962, a B-52 with a test device aboard broke ground from its Hawaii base, Naval Air Station Barbers Point, and headed for a spot in space 1,200 miles to the south. The Christmas Island phase of Operation Dominic was underway. In the Air Operations Center on Christmas Island, the tempo of activity picked up as preparations were made to acquire the B-52 at a point some 200 miles out. Overall command was kept in the Joint Command Post nearby, where the task force commander and his deputies monitored all facets of each mission. The precise time-space position of the B-52 drop aircraft was presented visually in the command post by closed-circuit television from a special tracking and plotting trailer. During the airdrops, all timing and positioning was keyed to the final leg of the B-52 pattern. As drop time approached, The Air Operations Center was exercising close control over a typical airborne array. Air Zero was here, off the southeastern tip of the island. The B-52 was flying a 16-minute racetrack pattern at 45,000 feet. The diagnostic C-130s were at 7,000 feet, 11 nautical miles from zero. The control RC-121 was in its altitude block between 12,000 and 16,000 feet at a distance of 65 nautical miles. The B-57s, monitoring weapon effects, were at 30 and 40,000 feet respectively, flying converging racetrack patterns 24 nautical miles south of zero. The B-57 sampler controller was at 37,000 feet, 30 nautical miles out. The C-54 and C-118 effects aircraft were positioned at altitudes between 7,500 and 20,000 feet at distances of 15, 20, 30, 40, and 50 miles north and northeast of zero. The rescue C-54 was at 6,000 feet, 65 nautical miles from zero. The photo C-54 was at 10,000 feet, 30 nautical miles away. A weather B-57 was at 30,000 feet, 40 nautical miles distant. A weather B-50 was upwind of zero at 11,000 feet. A specially instrumented KC-135 at 35,000 feet was 100 miles out. The control RC-121, although replaced by the Air Operations Center for overall control, functioned as the primary positioning agency for less critical elements of the array. They were also in a standby status to assume control of all elements should the situation dictate. There was steady improvement in the ability of the 121 to operate as an independent airborne controller, but it was gradually phased out of the Christmas operation as the need diminished. Aboard the C-130s, inherited from Everready, was the massive specialized diagnostic instrumentation gear. The equipment was designed to collect the technical data so essential to the scientist in evaluating the efficiency of his devices. Data on fireball size and growth, light intensities, time intervals, and electromagnetic pulses. Under these circumstances, the C-130s were largely experimental to begin with and were only intended to complement the rather extensive ground diagnostic stations on the island. Their participation, however, resulted in the development of an all-airborne nuclear test capability independent of land or surface stations. The B-57D sampler controller in the array had two basic responsibilities. Prior to the shot, he was to confirm satisfactory cloud sampling weather, and following the shot, he was required to monitor cloud growth and dispersal and vector each of the B-57 samplers into selected parts of the cloud to obtain particulate and gaseous samples for radiochemical yield determinations. Outside the primary diagnostic array were other aircraft, C-54s for photo coverage and for rescue, and specially configured B-57s for certain thermal effects and radar attenuation studies. During a number of the Christmas airdrops, C-54s and C-118s flew the 2,400-mile round trip from Hickam with test animals aboard. The purpose of this project was to conduct chorioretinal burn studies and to further develop eye protective goggles for aircrew use. Heavily instrumented KC-135 aircraft were also operating out of Hawaii for some of the Christmas events. These planes were modified primarily for certain studies in connection with the scheduled high-altitude events over Johnston Island. In addition to their test missions, the 135s had an in-flight refueling capability for the B-52 drop plane should the need arise.
25 seconds to detonation.
As 0 hour
20
approached,
seconds.
the Air Operations Center became the focal point of the operation.
15
Here
seconds.
within the darkened room, crammed with scopes, display panels, and
10
communications,
seconds.
the men watched and waited as the seconds ticked off.
5 seconds. 4, 3, 2, 1, 0. As the flash and fire dissipated, only the cloud remained. And it was toward this cloud that the samplers headed. While the sampling missions got underway, most of the planes in the array recovered at Christmas. As the B-52 and other Hawaii-based aircraft headed for home. During a period of roughly 4 hours after each shot, the samplers were sequentially phased into the cloud by the airborne sampler controller. Several penetrations were made during each mission. Once the sampling missions were completed, the B-57s also were released individually and vectored back to the island. On the ground, the sampler air crews were taken from the plane to the personnel decontamination facility. While the highly radioactive samples were removed, placed in special lead-insulated transport containers, and quickly loaded aboard a MAT C-135 for immediate non-stop return to the stateside laboratories for analysis. The radioactive samplers remained in an isolated parking area until radiation intensities had lowered to a level where their decontamination could be carried out. In addition to these now seemingly routine operations carried out by Air Force elements during the airdrops at Christmas Island, there were a series of new roles laid on literally at the last minute. One involved assignment of Air Task Group responsibility for the recovery of nose cones from cloud sampling rockets, a program quite unsuccessful during past operations. This last-minute task required the Rescue 54 and the helicopters to combine efforts and adapt as spotter and recoverer respectively in what resulted in a highly successful recovery of 18 out of the 25 nose cones launched. Another project involved a study of low-level delivery techniques. For this, B-57s, especially painted and instrumented, were flown in close proximity to detonations to determine thermal responses in such an environment. Precise positioning under such critical conditions was mandatory. To achieve this, MSQ-1 radars were acquired, airlifted to Christmas Island, and adapted to the specific program concept. Still another late arrival was a study of fireball attenuation of radar transmission. This program required deployment of up to 70 radar reflectors at points in space where the fireball would be between the reflectors and ground-based radars attempting to track them. The majority of the Christmas air array moved into a new environment with its participation in the Navy's Polaris system test, codenamed Frigate Bird. Another innovation was the extension of B-57D sampler participation to distances of over 500 miles from home base. This range extension was made possible by the utilization of a C-135 as the sampler controller
rather than the shorter-ranged B-57D. The frigate bird event provided two bonuses. It extended overall Air Force experience in the direction of an ever-ready type of operation, and, more importantly, it demonstrated the feasibility of sampler operations far out over the open ocean. However, not everything took place in the air. Ground operations carried on day in and day out as the operation unfolded. Maintenance, and more maintenance, servicing, supply, decontamination of the radioactive samplers, occasional relaxation, whether physical or spiritual, briefings, and more briefings, airlift of passengers or cargo, conferences, and more conferences. This basically was the routine pattern of life on Christmas Island as the operation progressed. From the first airdrop on the 25th of April, 1962, and during the following 78 days, a total of 24 thermonuclear devices were detonated. On 11 July, operations ended at Christmas Island, and with it came dismemberment of the painfully acquired and integrated airdrop team. The majority of the Air Task Group members left for home, while the remainder took off for Hawaii and Johnston Island. Completion of the airdrop phase simplified operational procedures to a great extent. For some time prior to the 11th of July, since early June in fact, major elements of the air array had been required to operate at Johnston Island, 1,200 miles northwest of Christmas, in support of the high-altitude program, while at the same time carrying on with the Christmas airdrops. Now, total Air Task Group effort was focused on the Johnston Island high-altitude phase. When the U.S. Air Force Thor missile was chosen as the delivery means for high-altitude tests, it was necessary for the Air Force to assemble a top-notch launch crew, oversee the major modification of several Thors, supervise the installation at Johnston Island of a Thor launch pad and all supporting equipment, and integrate the entire package into the specially designed tracking and range safety systems. Once more, under the relentless pressure of compressed time schedules, most of the material had to be airlifted by planes of the Air Force Logistics Command and Military Air Transport Service. Everything from missiles and warheads to cement and structural steel was flown in to meet the deadline for the high-altitude events. In support of these high-altitude firings, it was initially planned to operate all array aircraft out of Hawaii. The problems encountered by the Air Task Group while preparing for this phase closely paralleled those experienced during development of the all-airborne concept. There were major problems of control and positioning, and lesser ones dealing with planning and coordination. The selection of aircraft positions, particularly for the technical aircraft, involved so many variables that the configuration of the array itself was ever-changing right up until takeoff time. And on at least 2 occasions, the array was altered while airborne. For the high-altitude events, the RC-121s would be operating as airborne air operations centers for the control and confirmation of safe positioning of all aircraft. 2 other RC-121s carrying multi-frequency radars were on hand to provide data on bomb-produced radar clutter. Varying numbers of C-135s, able to operate at altitudes largely free from weather and dense atmosphere interference, had been modified to carry extensive diagnostic instrumentation for measurement of device performance and effects, as well as to evaluate and develop new diagnostic techniques. Using Christmas-proven procedures, 2 WB-50 weather aircraft were kept in the area as long as possible to ensure a clear line of sight for the critical complex of surface instrumentation below. The C-118 biomedical effects aircraft, which had participated in some of the Christmas missions, were a part of the array. And the SC-54 rescue aircraft was also on hand. One of the diagnostic C-130s operated much as it did at Christmas, except that it remained hundreds of miles away in these events to assess its long-range capabilities. In addition, Strategic Air Command elements of KC-135s and B-47s were airborne to test complex command communication systems during the blackout period, expected to follow the high-altitude nuclear detonations. And a special pilot-to-pilot communications network was built into the operation as a backup to ensure UHF and VHF radio contact with Hawaii in the event of a failure of normal communications. Sometimes at Johnston, and sometimes at the conjugate point of the Earth's geomagnetic field, 2,200 miles to the south in the area of the Fiji Islands, a KC-135 functioned as an airborne ionospheric observatory. It utilized radar and optical techniques to collect data on radio signal attenuation. Also in the southern area, 2 RC-121s were aloft, checking on radar clutter and interference caused by conjugate point phenomena. Finally, a U-2 was standing by at Hickam for its long pre- and post-shot weather sweeps over the Central Pacific. On the evening of 3 June 1962, the planes of the Air Task Group began taking off for what was to be the first high-altitude event, codenamed Bluegill. Within the Airborne Air Operations Center, 4 specially trained airborne directors manned their scopes. The safe position of all elements in the array was confirmed by the Air Task Group commander and relayed to the task force commander. Far below, on the island, the pre-launch countdown moved to 0. Bluegill and the ensuing Starfish event on the 19th of June were both unsuccessful. In neither instance was failure due to faults in the missile or warhead. After the customary 2-week stand down between high-altitude firings, the center of attention once more focused on the launch pad at Johnston Island. The date had slipped to the 8th of July. The event, Starfish Prime. 26 aircraft were again on station in the air array. Below the equator, the RC-121s were aloft. Then, 820.7 seconds after launch, success. Starfish Prime detonated as planned. Once more, on the night of 25 July, all forces were mustered for the rescheduled Bluegill shot. There were 25 aircraft in the array as launch time approached. But again, trouble. An oxygen valve failed, and for the 3rd time, the range safety officer had to push the destruct button. This time, with the missile still on the pad. In the light of day, it could be seen that damage was extensive. The entire future of the Dominic high-altitude program was in jeopardy. After detailed examination, it was decided to delay the remaining events while the Thor pad was rebuilt. Subject to quick recall, the majority of the Air Task Group elements were sent back to their home stations to wait out the rebuilding period. During the delay, there were several significant changes. As insurance against a recurrence of the Thor pad destruction, the decision was made to construct a second pad on a timetable even tighter than before. In addition, the Thor was to be backed up by both Nike Hercules and XM-33 missiles to the extent of their performance capability. The schedule was also changed by the cancellation of one high-altitude shot and the addition of 2 new ones. This addition committed the smaller backup missiles to primary roles along with the Thor. However, the change exerting the most impact on the Air Task Group was an unexpected decision to add more airdrops to the series, this time over the open ocean a couple of 100 miles south of Johnston Island. This development, with but 30 days available for preparation, led to the peremptory recall of the widely scattered Air Task Group staff and operating elements, and of the indispensable ground support equipment now en route to the United States. The major new problem associated with operation of the array over the open sea was the range limitation of the B-57 samplers, which made round trips from their Hawaiian base impossible. The only available solution was for the aircraft to recover, refuel, and be decontaminated on the already overcrowded and ill-equipped strip at Johnston Island. The air array for the Johnston Island airdrops was essentially the same as for the Christmas Island phase, with 2 major exceptions. No longer was the primary diagnostic instrumentation effort on the surface. The C-130 instrumentation platforms were, for the first time, on their own. In place of the relatively roomy Air Operations Center on the ground, the entire array was controlled and positioned by controllers in the airborne RC-121s, also for the first time. Finally, at the scheduled time, the air array was on station. On 3 October 1962, the first essentially all-airborne diagnostic mission was executed. The general concept of the air array developed for Ever-Ready and proven at Christmas Island had reached maturity 5 times all told. Between the 3rd and 30th of October, the planes of the Air Task Group went aloft from Hawaii and Johnston Island, flew their missions, and returned with a mass of diagnostic data, sometimes negative and sometimes positive, but always vital to the weapon designers in the development of their theories. During the same time period, preparations to continue the high-altitude shots were being completed. Finally, on the 15th of October, bluegill was attempted for the 3rd time. This shot, too, was unsuccessful. Fortunately, however, the backup missile capability generated during the interim rebuilding period brought with it the degree of flexibility necessary to continue with and accomplish the 4 high-altitude events almost within the original time schedule, including, at long last, a successful bluegill. This final surge, which included the last 3 airdrops, produced an average pace of activity significantly exceeding that at Christmas Island and under immeasurably more difficult operating conditions. 4 high-altitude events and 3 airdrops were accomplished in 20 days. To all involved, it was an exhausting racehorse finish that finally ended on the 3rd of November, 1962.
Operation Dominic was conceived, planned, and put on the road in less than 1/3 of the time required for any previous overseas nuclear test operation. Yet, it has been called the most successful and productive in the history of such testing. From the air staff to the operating and logistic commands which provided the personnel and resources, to the airmen on the line, Operation Dominic stands as a tribute to the skill, resourcefulness, and dedication of the officers and men of the United States Air Force.